Group C and Scientific Computation in Python.
In this video, we covered 5 topics of scientific computation in Python. First, the NumPy library, which is the core library for scientific computation in Python. It provides a high-performance multidimensional array object and tools for working with these arrays. Numba, which compiles Python code with LLVM to code which can be natively executed to CPU or GPU at runtime. Skypie library, a collection of numerical algorithms and domain-specific toolboxes including signal processing, optimization, statistics and much more. Xarray, aiming to bring the labeled data power of pandas to the physical sciences. Finally, HDF, which lets you store huge amounts of numerical data and easily manipulate that data from NumPy.
NumPy. To use NumPy, we first need to import the NumPy package. Array. A NumPy array is a grid of values, all of the same type, and is indexed by a tuple of non-negative integers. In NumPy, you can slice to pull out a subarray consisting with the value you require. Boolean array indexing lets you pick out arbitrary elements of an array. Frequently, this type of indexing is used to select the elements of an array that satisfies some conditions. Here is an example. NumPy tries to guess a data type when you create an array, but functions that construct arrays usually also include an optional argument to explicitly specify the data type. Basic mathematical functions such as addition, multiplication, or square roots operate element-wise on arrays and are available both as operator overloads and as functions in the NumPy module. Broadcasting is a powerful mechanism that allows NumPy to work with arrays of different shapes when performing arithmetic operations. To achieve a table, the broadcasting in NumPy follows a strict set of rules determine the interaction between the two arrays. Numba is a just-in-time compiler of Python functions. It translates a Python function when it's called into a machine code equivalent that runs anywhere from 2 times to 100 times faster. In this notebook, we show some basic examples of Numba. The most common Numba decorator is geat, which creates a normal function for execution on the CPU. Numba works best on numerical functions that make use of NumPy arrays. Here's an example. This first time a function was called, a new version on the function was compiled and executed. If we call it again, the previously generated function executions without another compilation step. Benchmark Numba compiled function, it is important to time them without including the compilation step, since the compilation of a given function will only happen once for each set of input types, but the function will be called many times. In this example, the Python function is more than 20 times slower than the Numba compiled version. However, the Numba function used explicit loop, which are very fast in Numba and not very fast in Python. Comparing NumPy version is more than 2 times faster than Python, but still 10 times slower than Numba. Creating universal functions. Universal functions, typically called ufuncs for short, are functions that broadcast an element-wise operation across input arrays of varying numbers of dimension. Most NumPy functions are ufuncs, and Numba makes it easy to compile custom ufuncs using a vectorized decorator. Single instruction multiple data, SIMD, is a class of parallel computers in Flink's taxonomy. It describes computers with multiple processing elements that perform the same operation on multiple data points simultaneously.
Broadcasting is the idea of writing code with a vector mindset as opposed to scalar. Say, I have an array and I want to fuzz with it. Normally, I would iterate over it and transform each cell individually. In Numba, we can run it in one go. Xray aims to bring the labeled data power of pandas to the physical sciences.
The goal is to provide a pandas-like and pandas-compatible toolkit for analytics on multidimensional arrays. Xarray's dataset is an in-memory representation of a netCDF file. Xray supports 4 kinds of indexing. These operations are just as fast in pandas, because it borrows pandas indexing machinery. Positional and integer label, positional and coordinate, dimensional and integer, dimensional and name. These are the 4 Xarray supported for indexing. The computation of Xray works very similar to NumPy and D arrays. Arithmetic operation broadcast based on dimension name. This means you don't need to insert dummy dimensions for alignment. However, aggregation operation can use dimension names instead of axis numbers. It also means that in most cases you don't need to worry about the order of dimensions. Operation also align based on indexed labels. Group by Xray supports grouped operations using a very similar API to pandas. Panda objects can easily be converted to Xray objects. Xray dataset is a dict-like container of aligned data array objects. You can think of it as a multidimensional generalization of the pandas data frame. Use dictionary indexing to pull out dataset variables as data array objects. Variables in datasets can have different d-type and even different dimensions, but all dimensions are assumed to refer to points in the same shared coordinate system. You can do almost everything you can do with data array objects with dataset objects, including indexing and arithmetic if you prefer to work with multiple variables at once. NetCDF is the recommended binary serialization format for Xray objects. Skypie, the main area where Skypie provides powerful functionalities, is linear algebra. Together with NumPy and Matplot, Skypie could eventually replace MATLAB. Transpond arrays rows into columns. We can inverse functions or solve for dense matrices. A sparse matrix or sparse array is a matrix in which most of the elements are zero. By contrast, if most of the elements are non-zero, the matrix is considered dense. Skypie is considered to be a bridge between NumPy and machine learning libraries like scikit, learn, or statsmodel. Scikits, short for Skypie toolkits, are add-on packages for Skypie, hosted and developed separately and independently from the main Skypie distribution. In this example, we show how Skypie serves as a bridge between NumPy and scikit-learn. We only want to see the first 5 lines of the dataset. Then we apply a normal test function to find the test statistics and p-value. We calculate the pre-weight normal test, the post-weight normal test, and finally the difference between the two tests. HDF is designed to store a large amount of data. The file structure is similar to the file system directory tree. Files, groups, datasets. These are the 3 levels of interest to access the information. It's helpful for high volume and complex data. However, it can also be used for low and simple data. The Hi5Py package is the Pythonic interface to the HDF5 binary data format. H5Py lets you store and manipulate data in a very large scale. H5Py uses straightforward NumPy and Python metaphors like dictionary and NumPy array syntax. For example, you can iterate over datasets in a file or check out the shape or data-type attributes of datasets. The following is the creation of groups and subgroups inside HDF files. Groups are subfolders. 4 different matrices are created with 1000 columns and 1000 rows. Reading groups with HDF files. Open the above file, this time in reading mode R as HDF. We will have a look at the items by creating them into a list-based item. Same as above, we check the items by creating them into list for group 1. We transform it back into NumPy array dataset 4. Under the shape, we can see quantity of dataset 4. We simply change number 1 for number 2 to access group. The following is the code which allows us to compress data while we save it in order to save space. Same groups and subgroups will be used. For compression, we have 3 different values: gzip, szip, lcf. For the level of compression, we utilize a tuple of values from 0 to 9. 2 megabytes have been saved by this compression. However, If we're using text, the compression will be much bigger. This was the explanation of the 4 packages. Hopefully it was helpful. Thank you for your attention.